In this video, we're going to talk about how to solve absolute value inequalities. Let's get right into it. Suppose we have the absolute value of 3x minus 7 and it is greater than 10. So how do we solve this? The best method is to write two inequalities. The first inequality is exactly the same, just without the absolute value bars. The second inequality is different. Take the expression inside the absolute value, flip the direction of the inequality, and change the sign of the number on the other side. So instead of positive 10, we use negative 10. Now remember this rule. If the inequality is greater than, you use the word or. If it is less than, you use the word and. Let's solve both inequalities now. Start with the first. 3x minus 7 is greater than 10. Add 7 to both sides. That gives us 3x is greater than 17. Now divide both sides by 3. X is greater than 17 over 3. Next, solve the second inequality. 3x minus 7 is less than negative 10. Add 7 to both sides. That gives us 3x is less than negative 3. Divide both sides by 3. X is less than negative 1. So the solution is x is less than negative 1, or x is greater than 17 over 3. And if you want to, you can check your answers. For instance, let's pick a number that's greater than 17/3. That's a little more than 5.5. Let's use 6. Plugging in 6 into the expression, we get 3 times 6 minus 7. So that's 3 times 6 is 18. Then 18 minus 7 is 11. So now we have the absolute value of 11 is greater than 10. Since 11 is greater than 10, the statement is true. Now let's plug in a number less than negative 1. Let's say negative 2. 3 times negative 2 minus 7 is negative 6. Then negative 6 minus 7 is negative 13. Now we have the absolute value of negative 13 is greater than 10. The absolute value of negative 13 is 13, and 13 is greater than 10. So the statement is also true. So by plugging in values, we can see that both sides of the solution are correct. Values less than negative 1 and values greater than 17/3 do make the inequality true. Now let's graph the solution on a number line. First, draw a number line with 0 in the middle. To the left, we have negative numbers, and to the right, positive numbers. We'll start by marking an open circle at negative 1. Then we draw an arrow going to the left. To the right, we mark an open circle at 17/3. Then draw an arrow going to the right, showing all values greater than 17/3. In interval notation, that is, from negative infinity to negative 1, union from 17 over 3 to positive infinity. Now let's try a different example. Suppose the absolute value of 2x plus 6 is less than or equal to 12. This time, since the inequality is less than or equal to, we are dealing with and statement. Write two inequalities. First, 2x plus 6 is less than or equal to 12. Second, 2x plus 6 is greater than or equal to negative 12. Let's solve both. Start with the first, subtract 6 from both sides. 2x is less than or equal to 6. Divide by 2. X is less than or equal to 3. Now solve the second. Subtract 6 from both sides. 2x is greater than or equal to negative 18. Divide by 2. X is greater than or equal to negative 9. Draw on a number line and mark a closed circle at -9 since it is greater than or equal to. Then mark a closed circle at 3 since it is less than or equal to. Join the 2 points with a solid line. When you have an absolute value with less than or equal, the graph will always be a segment. In interval notation, bracket -9, comma 3 bracket. Let's now look at two important examples where we need to flip the inequality sign. Suppose we have the absolute value of -2x plus 4, and it is greater than or equal to 6. We'll write two inequalities. First, -2x plus 4 is greater than or equal to 6. Second, -2x plus 4 is less than or equal to -6. Let's solve the first one. Subtract 4 from both sides. -2x is greater than or equal to 2. Now divide both sides by -2. Since we're dividing by a negative, we flip the inequality. X is less than or equal to -1. Now solve the second one. Subtract 4 from both sides. -2x is less than or equal to -10. Divide by -2. Flip the inequality again. X is greater than or equal to 5. So the solution is x is less than or equal to -1, or x is greater than or equal to 5. Let's graph the solution on a number line. X is less than or equal to -1. Put a closed circle on -1. Remember, we use a closed circle for less than or equal to, or greater than or equal to. Then, draw an arrow going to the left. Next, put a closed circle on 5 and draw an arrow going to the right from 5. Suppose we have the absolute value of -3x minus 9 is less than 12. Because this is a less than situation, we'll use and. Write two inequalities. First, -3x minus 9 is less than 12. Second, -3x minus 9 is greater than -12. Let's solve the first. Add 9 to both sides. -3x is less than 21. Now divide by -3. Flip the inequality. X is greater than -7. Now solve the second. Add 9 to both sides. -3x is greater than -3. Divide by -3. Flip the inequality again. X is less than 1. So the solution is x is between -7 and 1. Let's graph the solution on a number line. Place a closed circle at -7 and another closed circle at +1. Connect the 2 points with a solid line. This shows that all numbers between -7 and 1 are included. In interval notation, we write the solution as bracket -7, 1, bracket. Now let's cover some tricky problems you should watch out for. Suppose you have the absolute value of 5x plus 2, and it is less than -4. Think about it. Can the absolute value of any expression ever be less than a negative number? No, it's impossible. The absolute value of a number is always 0 or positive. Since this inequality is asking when something is less than -4, there is no solution. Now here's a similar looking expression. The absolute value of 6x minus 1 is greater than negative 7. This one is different. 0 is greater than negative 7. Any positive number is also greater than negative 7. Since absolute values are always 0 or positive, this inequality is always true, no matter what value of x you plug in. So the answer is all real numbers. In interval notation, we say parentheses negative infinity, comma, infinity parentheses. On the number line, we shade the entire number line. Let's look at one last example that brings everything together. Suppose you have 4 times the absolute value of x plus 3 minus 2 is greater than 10. Notice that there are numbers outside the absolute value. Don't break it into two cases yet. First, isolate the absolute value. Add 2 to both sides. Now we have 4 times the absolute value of x plus 3 is greater than 12. Start by dividing both sides by 4. That gives us the absolute value of x plus 3 is greater than 3. Now write two separate inequalities. First, x plus 3 is greater than 3. Second, x plus 3 is less than negative 3. Let's solve the first inequality. Subtract 3 from both sides. We get x is greater than 0. Now solve the second inequality. Subtract 3 from both sides again. We get x is less than negative 6. So the solution is x is less than negative 6 or x is greater than 0. Graph it with open circles at negative 6 and 0. Shade to the left of negative 6 and to the right of 0. In interval notation, parentheses negative infinity, comma negative 6 parentheses, union parentheses 0 comma infinity parentheses. And that's how you solve absolute value inequalities. If you found this helpful, feel free to subscribe to the channel. Thanks again for watching.